I have the pleasure that I have the opportunity to present you the Aero project. So Aero stands as an acronym for Accelerated European Cloud. And the key motivation that motivated our consortium for this project is that we have nowadays many cloud infrastructures provided by vendors that they're mainly providing a rich ecosystem of heterogeneous hardware and software for the cloud applications. So there are many workloads that they can use different types of hardware units and different types of software services that they are tailored to their application and their customers. But they're mainly driven by US companies, and this poses some difficulties. So there are strong dependencies to overseas technologies. There is an increased security and data privacy concern. And also there is a lack of flexibility if some European enterprise companies, they want to have custom designs. Now, in terms of hardware, there has been an endeavor from European Commission and particularly the European Processor Initiative that had this ambition to create new designs, new hardware designs, and fabricate the first European-made chip, so the first European processor. And along with the processor, have some additional compute units. Now, to achieve sovereignty in European Union, in parallel with the hardware track that they're developing the first processor, we have had also these RIA projects that are funding at the same goal. And the goal is to bring up the software ecosystem for the new hardware processors. And this has been the vision of Aero. So we have been, the whole partners of our consortium, they share the same vision to port and optimize existing state-of-the-art technologies, mainly open source, but also some closed source technologies that they can be found in a traditional, let's say, cloud software stack. And as a key objective, we want to enable fast adoption for European companies. So the ability to migrate from existing infrastructures to the new emerging EU cloud ecosystem. Now, in this slide, we want to present the target platform, which will be the first commercially available processor that comes from EPI. And in particular, it is a processor coming from a French company, which is called Cyperl. And this will have an ARM Neoverse V1 processor, along with some RISC-V coprocessors. And also it will be heterogeneous. That means that it will have also some hardware accelerators to offload execution of applications. And in particular, it will have GPUs, which will be interconnected via PCI Express. And is expected to be available in Q1 2025, so next year. So in the meantime, because our project now has been started for quite some time, since last year, we have been working in some alternative platforms. So platforms that they have similar or the same instruction architecture with the RIA processor that comes from Cyperl. So that ensures that we have already started the porting of our software stack in this target architecture. And this is a plethora of platforms that are functionally equivalent, let's say, to the Cyperl RIA processor. So recently we have started also using the NVIDIA Grace superchip, and we are also using FPGA boards to prototype new hardware designs. Here I have clustered all the software stack that we have in Aero in 6 different layers. So the focus is, the first focus is on virtualization. Therefore, we have the virtual open systems who are bringing their in-house VOSIS monitor technology. And this is to enhance security in the virtualization layer. So they are leveraging the ARM's trust zone in order to isolate workloads between secure and non-secure worlds. So their goal is to enable secure virtual machines that are running to have access to the hardware accelerator support, and also to efficiently communicate with other non-secure virtual machines. Now, in the second layer, we have hardware security extensions. So we have the University of Pisa, who are bringing some designs that have been developed from the first phase of EPI, and the goal is to port them with the Cypel RIA processor, to work with the Cypel RIA processor, but they are also researching and creating new algorithms for homomorphic encryption in order to deploy them on a cloud and edge environment via Microsoft Seal. Then our focus has been also in programming languages. So one group is the managed programming languages, where we are developing dynamic memory management for JVM. And we have also focused on enabling hardware acceleration for JVM programming languages via Tornado VM, a technology from the University of Manchester. And we are also focusing on enabling fast startup times for Java applications. And this is led by Red Hat. Now, a second group of programming languages, it is the native programming languages, and we have CodePlay, who are bringing SQL, which is a vendor-independent programming model for accessing hardware accelerators from native languages. And they are also focusing on adapting a compiler, which is the One API DPC++ compiler, in order to support both ARM architectures and RISC-V acceleration. Now we have also cloud-based enterprise microservices. So Red Hat brings Quarkus, and their focus is on the native mode, because the JVM mode has been mature. The native mode was not that mature, so it was in early steps. And they have ported and optimized it for the target hardware platform. And in fact, recently in April, they released also the Red Hat build of Quarkus Native, the version 3.8, which is going to be used by our project also for final integration and testing. And finally, we have the cloud containerization and orchestration layer, where we bring Maestro as a cloud orchestration platform from Ubitech. We have also Knot and Hexaflow for managing Kubernetes. And this has been ported to ARM, and it is interfacing with RISC-V accelerators, and it's coming from Forth. And finally, we are working also on enabling function as a service, so to have this ability of serverless computing, which is currently available in commodity-ready cloud infrastructure. Now, as use cases, we have 3 pilots for the Aero software stack. The first one is coming from automotive, and it's coming from KTM, a company of Pirer Mobility Group. And we have also 2 use cases from Switzerland. The first one is coming from the University of Geneva and focuses on high-performance algorithms for space exploration, while the last one is coming from SETNAI and focuses on the acceleration for scientific computing that will be stored in cloud databases. I will focus briefly on each of the use cases before summarizing the project. So the first one is a digital twins use case for IoT and cloud deployment. And the idea is that the backend services that are running from Pirer Mobility, that they will be tested on the target hardware platform by running the software of Aero. And in particular, they have one service that they want to identify vehicles that the information of the vehicles has been stored in databases. And they will use Docker and Apache Kafka's key components from the Aero software stack. Now, regarding the other 2 use cases, the first one is the goal is it is coming from the Gaia mission. So it is from the European Space Agency, where they have collected an enormous amount of data and from the space, and the goal is to process them fast. So these algorithms, they are developed already in Java, and the idea is to use Tornado VM to accelerate them on the GPUs that will be available on the RIA processor. And finally, the last use case the idea is that there's a synergy also with the other use case. So data, this large amount of data, which is in the petabyte scale, will be stored in a database, and then Tornado VM will be used also to accelerate the operators that will be running on the database. Now, this is the last slide that I have for Aero. So this is the current status. We are in the middle term. We have finalized the baseline phase, which ensured that we have performed the compatibility of our software technologies on the alternative platforms, which are very close to the target architecture of the Cyber RIA processor. And we have transitioned now to the optimization phase, where we are performing optimizations and stability tests for our software stack. And finally, the bottom part of the slide, I have the key components of our software stack, and I have emphasized with bold the open source technologies that we are working in Aero. And this is the last slide. This is a photo from our consortium in the last plenary meeting that we had in Aero. And these are the handles as well, if you would like to follow our project and our progress.
Thank you so much, Tassos. We can go on with the second one, and I'm welcoming Stefano Marchidis. Good morning.
Oi, sexy. Obrigada, tudo bom? Gosto de careca sentado.
I'm reminding
Ai,
you
gente,
to keep your microphone mute, please. During the presentation, we will have a panel discussion in which we can talk freely. Stefano, when you are ready.
Yeah, good morning. Good morning, everybody. Thank you very much for the very kind invitation. My name is Stefano Marchidis. I'm a professor of computer science at KTH. I'm also project manager of the OpenCube project. So the title of the presentation is OpenCube towards a European pre-production cloud platform. So what is the vision of the project? Well, the overall goal of the project, that is where we want to be by the end of the project, is to design and develop and build a blueprint of a cloud system on top of API technologies that, as has been said in the previous presentation, consist of the European CPU, that is the Cyber ARM RIA processor, and the RISC-V accelerator, that is a vector assimilator, in this particular case, the Semidynamics RISC-V processor. As a second objective, we want to deliver a production-ready system that is validating the blueprint infrastructure that we designed during the project, and we want to validate the blueprint with a full open source full software stack. And most importantly, looking at the impact, we want to push for awareness and adoption in cloud providers and users. These slides represent a brief summary of the project. The project is coordinated by KTH, that is a technical university in Stockholm, Sweden. It's 3 years project, starting in January 2023. It's a consortium of 5 members plus 1 associated members. So we have KTH, Technical University of Munich, Cyber, Semidynamics, ECM, WMF, and then as associate partner, HPE from the Zurich team, the R&D Zurich team in Switzerland. As I said, the most important objective is to deliver a production-ready OpenCube blueprint infrastructure that can be taken as a product and commercialized. So how the OpenCube blueprint infrastructure look like? We're going to have we are having computing nodes composed of heterogeneous compute and a memory for a diverse number of workloads. Also accelerator, but also different kind of memories. We want to have a high performance Ethernet network for low latency and combined with high bandwidth to support workloads that are at the convergence of HPC and the cloud. And we want to have dedicated memory and storage nodes with a large number of NVMe SSD for efficient data staging and or orchestration. As in the first part of the project, we work and delivered a prototype system, so real hardware. So we have an OpenCube cluster that is in Grenoble that consists of a system using emulation of two types of computing units. So instead of the Cyper RIA processor that will be delivered later on in the project, as we heard before, 2025, we are using the ARM Ampere processor, and also we use FPGA boards from Semidynamics, and these boards are Atrevido RISC-V vector processor. As you can see here, the diagram and the process. As I said before, we have a cluster deployed in Grenoble. At the moment, we have 4 compute nodes and 2 infra nodes, as is shown here in the diagram, interconnected by slingshot HPE network. In the phase 2 of the project, we will update the pilot system with the 12-node based on Cyper RIA processor and the Semidynamic Atrevido RISC-V processor. So as a project, we want to deliver the blueprint that is consist of a hardware platform that we design, but also consists of an entire software stack that we want to offer as a blueprint. So this software stack consists of different layers, and then at the bottom there is operating system and system software consisting of the base operating system based on Talos and Kairos, and modules on orchestration, scheduling, built on so system management framework on top of OpenChami, and extension Kubernetes scheduler and autoscaler. We have a part related to the monitor, and we're extending the CDB for sensor plugins and containers basic metrics. And then we have a number of software targeting, programming, and tooling, including container-based environment, base image extensible by containers, images from user, and extending Linux, perf, and PAPI for assessing performance counters. In the middle part of the software stack, we are using ARM compiler, so GCC, OpenMP, and the RISC-V toolchain for cross-compiling and selector libraries. We have a quite strong interest and work on supporting heterogeneous memory and disaggregated memory. So at node level, using kernel-based memory tiering support, at distributed memory, looking at disaggregated memory, we're looking at the communication transport libraries like OpenFAM and FTP, that is an object store for meteorological data. In addition, we have the software for high-performance network software, including Kubernetes CNI plugins and secure RDMA communication. So the blueprint of OpenCube is validated and demonstrated by a number of applications. We have a number of data-intensive data-centric benchmark, including Spark, Airflow, Memcache, and Redis. We have in the project one of the most important molecular docking software called Autodoc that is used for drug discovery. We already implemented the workflow to enable molecular docking workflow. And we have the global weather forecast workflow that consists of simulation, weather forecast simulated with the observational data. And last but not least, we have workloads related to machine learning and deep learning applied to data from space. So this is the last slides. So in summary, what we intend to do is to produce a blueprint, basically a description of the hardware stack based on API and the software stack that is open source, that is proven to work, and that it can be used and used and commercialized as a solution. Thank you very much.
Thank you, Stefano. We will leave the question for the panel, and we are now welcoming Dr. Vasilis Papastathio. Thank you for being here. You are on mute. Okay.
Yeah. Hello. Good morning.
Good morning.
Thanks for this kind invitation. I will now share the slides. I hope you see them.
Yes, we can. Thank you.
Great. So I'm Vasilis Papastathio, Professor of Computer Science at Forth, and I will present you today the RIAs project, which stands for the RISC-V for Cloud Services. So this presentation will show the viewpoint of the RIAs for cloud services running on RISC-V platforms. This is a project that was granted on the call on cloud-based services, and this is managed by HADEA, the European Health and Digital Executive Agency. And of course, as a disclaimer, all the views and opinions here do not necessarily reflect the European Commission and the HADEA executive agencies. Now, the main question that we are trying to answer, and it's the objective of the project, is how can we design and build data center system platforms based on open standards in Europe and today. Now, open standards exist in multiple layers. In terms of ISA, the instruction set architecture, today the dominant ISA is the RISC-V ISA. So we're basing our work a lot on the RISC-V. And of course, the landscape here for the RISC-V community is a bit complicated. There are several opportunities and several gaps have been identified, both in the hardware and software. And there is a nice interactive visualization on the website of RISC-V about the availability of software packages, platforms, chips, etc. for this ecosystem. In this project, we are considering two primary platform types, the PCIe accelerators and server boards, and we have identified gaps in the availability and the availability and integration of suitable IP blocks. So there is no real we need to have a more efficient use of high-speed I/O peripherals to serve the cloud services. And of course, other open standard fully featured stacks need to be supported for all the services. And we also base our work on hosts and accelerators, which is very common today, and we want to be able to offload things in accelerators, and we have to improve the interaction between host and accelerators for these calls. Now the RIAS consortium consists of 7 partners, 5 industrial and 2 academic, is coordinated by Forth, located in Heraklion, Greece. And the other partners include Exapsys, specializing in board design, Semidynamics, specializing in the core RISC-V course and also participating in the European Processor Initiative. BSc also specializing in lots of research work and the vector units, also in EPI. Cyprel is developing the ARM general purpose processor for the European Processor Initiative. DPI, Extol is developing high-speed serial links and high-speed interconnects, and Cloud Sigma is a cloud service provider. Now, with this set of expertise in the consortium, in Riser, we are building a RISC-V-based Linux server for cloud services built on open interfaces, and starting from the side of the processors and the chips. So the source of the chips for this project is the API and EU pilot projects, where many of the partners participate and have central contributions, as I said, for Semidynamics, Cyprel, BSc. And we're going to use outcomes of these projects to build systems for cloud. Based on these chips, the project develops server boards, the PCBs and the firmware in the form of standard form factors, PCIe accelerator card, and microserver. And these boards also have to include all the necessary components like DRAM memory, non-volatile NVMe storage, 100 gigabit Ethernet. So they are put together in such boards, and then, of course, in order to start these systems, we need all the stack, boot firmware to initialize the execution of the platform, including all the high-speed I/O peripherals, the storage, the networking. On top of that is the operating system, the drivers, the runtimes. So it's a full stack based on open standards and open source, and is configured and adapted in this particular project for cloud services, for workload acceleration, network storage, and containerized execution for infrastructure as a service environments. The website of the project appears on the top left of the screen, and of course the social media, Twitter. The coordinator of the project is my colleague, Dr. Manolis Marazakis from Ford. Further questions can be directed to him at any point in time. And as a project, the idea is to have an integrated all-European hardware and open source solution for cloud services and applications. Moving further to the open standards and open source. So in terms of open standard, we are using several hardware platforms, including FPGA emulation of IP cores that are developed by the partners of the project who also participate in the European Processor Initiative and the EU pilot project. The PCI acceleration card that will be generated, developed in the project in the microserver. In terms of open source software, the firmware, the operating system, the drivers for accelerators and the cloud, this is part of the project, and the software stacks that we are using in this project are mostly focused on two parts. One is the OpenMP target offload for PCIe accelerator, which is the most widely deployed runtime system for parallel execution. So offloading from a host via OpenMP to the PCIe accelerator in order to accelerate several use cases, compute intensive, and of course all the ML and AI workloads that are becoming available. Additional use cases include network storage and containerized execution for Kubernetes. So for cloud servers, it's very common to have containers. Kubernetes is the most widely used framework, and it's part of the goals and the objectives of the project in order to support the infrastructure as a service. And of course, all of these to work together, we need a rich system software infrastructure, lots of tool chains for both ISAs, for RISC-V, and the RIAs to collaborate. And there is additional work on operating system and software packaging, preparing distributions, low-level libraries, tools, and many more that are needed. And in order for all of this to work in different systems, there needs to be device discovery and initialization. And for all the cloud development, the deployments, there has to be system management and monitoring infrastructure to put all these things together. So with this, this concludes the presentation of the RIAs project. Thank you.
Thank you. Thank you so much. We are going to the last project, that is Vitamin V. And I'm welcoming Ramon Canal. Hi, Ramon. Thank you to be here.
Hi, good morning. Thanks for the invitation. So I'll share my screen. Okay. So I'm Ramon Canal. I'm a professor at the Universitat Politècnica de Catalunya in Barcelona. And I'm the coordinator of Vitamin 5, the project. So Vitamin 5, as the other projects that were presented early on in this webinar, is part of the call that started basically on January last year, and it should be the project should be ending by the end of December next year. So we are a consortium of 10 partners, UPC as the coordinator, but also the Politecnico di Torino, the Fondazione Links, also in Torino, the University of Athens, ICCS and Exapsis in Greece, the BSc, also in Barcelona, Virtual Open Systems in France, 0 Point in Sweden, and Semidynamics also in Barcelona. So all these 10 partners, basically, we are trying to push RISC-V, so we are solely concentrated on RISC-V and basically pushing RISC-V and expanding its capabilities into the cloud. So for that, we need all the software stack and actually some virtual platform or some hardware platform so we can run all of that. So all the partners I listed basically can be mapped into all these stacked I depict. So based on Semidynamics experience in EPI and basically the initial realization of their core, they are extending it with what we call cloud relevant ISA. Fundamentally, there are a couple of ISA extensions that are especially needed in the cloud. So they are developing that in the project. Similarly to 0 Point, which are developing the memory compression, which they initially developed for APC through EPI, but eventually now they are porting that to cloud, where basically more data is managed and effectively used. And that's basically their business. So they are also in the plans of commercializing it. So that would be the bottom part. On top of that, apart from designing, we need some platform to run. So clearly, RISC-V platforms and the chips available nowadays are not very powerful, so it's hard to run a full cloud stack on top of that. So fundamentally, we have 3 different platforms which allow us to study the different trade-offs in different design stages. So from the architectural part, we have Gen 5. We are contributing to the open source Gen 5 architectural simulator. That's a CPU simulator. And we are contributing that with all the required ISA extensions for cloud and all the functionalities we need to run virtual machines, for instance, and on all the workloads. What we already have is the QEMU. And with that, we are able to run all the software on top of that. So basically, having any kind of current server that we can buy in the market, mostly x86. And on top of that, we can run QEMU and then all the virtual stack. And we will soon be releasing Amazon F1 instances based on the Semidynamics core so that effectively not only the consortium can run their applications, in this case in the Amazon cloud, with semi-dynamic score, and they do not need to buy their own FPGA, but we also plan to release that to the public, at least on the first stage for free, so that effectively we can foster the ecosystem development of RISC-V. The third level would be the virtual machine and cloud management stack. All the software suites I list here are open source, like Kubernetes, which has been mentioned, OpenStack, Rust VMM, and Kata containers. So we are contributing to the ports of these virtual machine managers and cloud management in general to RISC-V, so that effectively, once we have the chips, all the applications can run smoothly. Finally, in terms of applications, in this case, we are focusing on AI and big data frameworks, Apache Spark, TensorFlow, OpenFast, and others, basically because they can be a good example of the use that we may have in the cloud for RISC-V, and actually that's what we are doing now. All of that basically would be just different software suites at different levels. We also need to make everything compatible and be able effectively to compile and run that. We are using BSC Experience with LLVM, which is again another open source suite, in this case the compiler, to build the compiler and all the toolchain needed so that we can effectively be successful in the porting. All of that basically provides the core of our work. We also believe that now that we are bringing this up, this new RISC-V based cloud, we should work on the trustworthiness through verification, validation, and test. So we are providing security, extra layers of security, and extra tools for validation, so that effectively, whenever we reach our goal, that we can provide these open source tools to the general public. Basically, they are reliable and they have ways to test that any software running on their applications or chips. Basically, it's safe, and basically it doesn't contain any malware or any of that, for instance. So all these different software suites, they focus or they target different cloud setups. We identified 3 different cloud setups. So the classical, which would be virtual machine based, and that typically runs on OpenStack, and we will be showcasing that with OpenStack, and then running either a Spark for big data or TensorFlow for AI. Modern cloud, which is based on containers, as has been described earlier today, so that basically it runs on Kubernetes. And we are also targeting serverless cloud, in this case using both Kata containers and Kubernetes, and then using a specific Knative and OpenFast as a way to measure the performance. Our target is that the software runs as fast as it does on x86. So in order to do that, as we don't have a comparable hardware platform, basically we'll use the CoreMark score basically to take the performance of the CPU out of the performance of the system. So this is the core of our proposal, and that's a pretty high-level description of what we are doing. In a month from now, or a little bit over a month from now, we'll be participating in the RISC-V Summit EU in Munich. And basically there, either in the main conference or in a separate workshop, which is dedicated to RISC-V open source software, which Vitamin 5 and Riser are organizing. Basically, we'll be showcasing our OpenStack implementation, which we already did in the Mobile World Conference in Barcelona. But we'll also be presenting all the developments we have provided, either with the core itself, in this case, semi-dynamics, with 3 different of the software suites like Kubernetes, OpenStack, and Rust VMM, all the compiler and toolchain based on LLVM, BSC, and then all the security part that I was mentioning before. So with that, I go into my conclusions. So Vitamin 5 is focused on cloud computing and RISC-V, and fundamentally, a big chunk of the work is porting all the applications so they can run effectively on top of RISC-V. So we embrace RISC-V and open source. As I mentioned, all the software suites we are using are open source, and basically all what we do, we plan to push it to the upstream, to the main branches. And we believe it's a collaborative effort which may span beyond the timeline of the project. But I think it's a good start that all this work is done, and effectively then other groups or the researchers basically can have these tools already available for them. We contribute to the higher impact of the results, especially in the RISC-V areas. So in our case, in the computing continuum of IoT, edge, and cloud. And basically, we are in touch also with other initiatives in the RISC-V area financed by the European Union, not only in this case, especially RISER in this set of project, because they are also focused on RISC-V, but all the high performance computing programs that have been running in the last years, and also the automotive programs which are either running or starting to run in the chip JU calls that are coming. Finally, and with that I finish, I encourage you to participate in the RISC-V Summit, and especially on the Friday site events where we are organizing this workshop on open source RISC-V software, where we will have presentations from the RISC-V Foundation, the RISE project, the three main OS distributions, so that's Ubuntu, Canonical, SUSE, and Red Hat. And apart from that, there will be a bunch of academic presentations, not only from the projects here, but also other initiatives that we have known in our way, and they develop open source RISC-V software. With that, I conclude, and I thank Rosario for the organization and all of you for listening. Thank you.
Thank you. Thank you, Ramon. So now we are going to have this panel discussion on the topic that we saw today. We had some amazing presentations, so I'm still thanking you. And I want to start, and I would like to ask you what is your opinion on that, but what is the impact of the open source software technology in your work and in the European ecosystem? What do you think about that? Since you are using open source, what is your opinion on this, on my question, on the impact that the open source technology has?
Yes, I can start. I mean,
please.
Yeah, investing in open source software is at the heart, let's say, of our project. I think it's a key aspect of for European research and innovation actions and these projects, in order to ensure a legacy of software that is something that can be consumed by future projects as well. So instead of reinventing the wheel. So being open source is, well, we can see that from our slides as well. We are working on common technologies. For example, LLVM is just something that we are also contributing. Vitamin V contributes, RISER most likely. So this is something that we can share and bring up a software that can be extended and can be reused for different aspects. So in a complementary way.
I don't know if someone else wants to contribute to this question.
I also think that open source basically allows a lot of different people in different places to collaborate and contribute, and basically that fosters innovation. So in our case, in Vitamin 5, I mean, we couldn't, the project could not build a TensorFlow. The project cannot build an open stack. I mean, it would be the sole purpose of the project. But we can use what it's done and basically add all the RISC-V part and eventually contribute at the community, which can develop it further. So effectively, I mean, we are speeding up the development time and basically effectively the way that industry and SMEs basically can use and basically make productive this effort to foster their own businesses. But I think it's a good way to basically make that available to the public.
Yeah, that is always let's say it's something good when you can reuse, okay, and you can have some let's say leverage from the past. But Stefano, do you want to add something?
Yeah, so I echo what has been said. I guess is a key for the sustainability of software. So these projects are not a short time frame. So there's also to survive, to have a legacy, and to rely on what has been done before. I think it's also important to be aware, which kind of open source. So especially when it comes to licensing, and ensure that a lot of software open source software can be commercialized. I think is also important to have a mature and idea on which kind of open source, so that can be also promote the reusage by industry, and to make a product. So overall, I think is as has been said, is really key for sustainability of the software, legacy, not reinventing the wheel, but also for having impact on an industry by looking at probably less restrictive, like open source licensing scheme that can be reused by companies.
Yes, in fact, we have I can let's say relate your answer to a question that we have in the chat, because the question is they thank you for your presentation. Will your code, because we are talking about open source, will be hosted in any open source foundation, or do you have some plan to make this kind of to, let's say, care about your code, like putting a license or continuously growing with your community? Do you have such interest, or do you foresee something in your project like that? Do you already choose some license for this, for example, some open source license, as now Stefano mentioned?
I can say for Aero that we are working on open source, so it's going to be an open source open operating system in our software stack. And regarding licensing, each one of the technology that we have in our stack has their own licensing. So being open source is different from licensing the software that is open source. And there, for example, in Tornado VM, which is the software that we bring from the University of Manchester, we have different kind of licensing schemes that because Tornado VM is like a complex software system. So there are some parts that are coming from the JDK compiler, and this should be they adhere to the copyleft part, but some others, they are permissive, so they're you can extend it, and for example in the API can be Apache 2, so it depends, but the majority of the licenses that we have in our software stack in Aero, they are permissive.
Okay, so it's interesting also, please.
Yeah, just to add it, I think it's very important, as Etano said, to have permissive open source licensing. Many of these projects include commercial partners, that they see benefit in open source in building, but if the license is not permissive, that is going to be a blocker for the project itself. So as an OpenCube, we have an inventory of all the licensings, within the project to allow commercialization and those are permissive open source libraries, just to answer the question. So I think is a key to have impact, to have inventory of the licensing present in the project to see how these companies and European industry can build on the top of it.
Yes.
In the case of vitamin 5, so obviously all the companies which may have commercial interests, basically like Semidynamics or 0 Point, they are developing their own business on that. So that's clearly a case of industrial exploitation. For all the software suites I was mentioning, we plan to basically abide to the licenses obviously of those suites, but also we don't want to create like a second branch, which would be the vitamin branch. I mean, we actually plan to upload everything we do to the main branches, so effectively they can be part of the next distribution of that software, and that effectively other institutions, other researchers can adopt those or even modify it or make them better or just add functionalities. So the plan is to push everything upstream so that all the community revolving, which is already created around those software suites, basically can benefit from that.
Yes, I think we know.
I could also,
please.
Yeah, I could also add a bit from the side of the RISER project. So depending on the contributions, depending on the software, the open software, I mean, we are starting with some open software and it has some initial license, right? We are, let's say, contributing to Linux. So there you have to keep going with the licenses of this software package. For the other software, frameworks, etc., you still have to go this way, otherwise it becomes a bit more complicated. Hopefully, many of these open frameworks have permissive licenses, so that helps a lot in order for the exploitation of the industrial partners and the commercialization of several ideas. Of course, if there is new software appearing, I think the best idea is to use permissive licenses, and that's what we are trying to do. And of course, from the side of the RISER, all these contributions will be open sourced. Of course, I cannot say the exact repository, but depending on the case, it might be project repository or some GitHub or stuff like that.
Okay. Yeah, open source. We know that open source is important because we are using open source, and we will provide. You are providing more contribution to the open source. It's important to do it in a right way. What I would like to also to ask you, talking about open source and cloud services, is okay. We established that open source is important, that we need licenses. But what I want to hear from you is about the challenges that you had in your project with open source, with this building these cloud services. If you can name one challenge that now comes in your mind.
I would say that one challenge that comes in my mind comes from also what Ramon said earlier, that our ambition is to contribute code to some repositories that are already there and they have a large community like LLVM. So our goal is to, let's say, contribute to these code bases. But one challenge would be if the community doesn't accept this kind of contribution. So that could have a challenge. That could be a challenge and would have some, difficulty for our project. So in this case, a solution would be to have it open again in the fork that we are using in our project. But that could be something that will hinder, let's say, the actual contribution to the ecosystem. But this is a challenge that I see for developing on an open source ecosystem, let's say.
Okay. Maybe I before maybe let someone else ask. I want to add that maybe you also face some problems and challenge, not problem, to make some partner adopting open source or the pilot, or maybe there are some other challenges that we can think of.
Yeah, certainly, I guess adoption is, all the projects here that, they have impacted through adoption. As you said, probably one of the challenges to work with some proprietary license software, right? And trying to find scheme through which can be, feed into open source. So when you work with some companies, you typically have to deal with some proprietary software. So then also requires a very careful attention to IPs, right? So what is intellectual properties, and how do you preserve intellectual properties of a company? How this can be into the big picture of open source. So these are big challenges. We are all surrounded by our innovation offices, to deal with IP and work together with the companies, as also companies see this as a big opportunity to have impact. So open source, as we said before, is impact, but I would say one of main challenges that we have to deal with, some proprietary software, how the interaction with proprietary software is going to work, requires some thinking and work with the all project wise, especially with the innovation office. And the other issue, I guess, is we're dealing with brand new architectures, right? That we have a lot of prototypes. And so the RIAs, as we heard, is coming later on next year. So we also need to deal with a lot of unknown when it comes to the hardware itself.
Yeah, I see. On this topic,
that we also face, we share the same challenge, let's say, regarding the unknown hardware and this delay coming.
On this answer, I found that I want to take the opportunity to say that the IP, the licenses, the IP rights are services that in the open source foundation you can find, so that can be helpful. That's related to the question that was shooting before in the chat. Yes, Vasilis, I saw your hand.
Yeah, I was about to contribute a bit to the challenges that we are facing in Riser before you started discussing this. But I think one of the things that we are seeing is that there's an ever increasing volume of contributions to open source software. Too many frameworks are jumping in different cases. I won't talk about AI machine learning. I don't know, every 2 weeks I see a new framework. So it's a bit challenging to manage all these things and decide on what to use, what to adopt, where to contribute, what is the best thing to do. This is one thing, and on top of that, of course, existing frameworks get updated every day, and oftentimes they just keep using new other open source packages, libraries. So there is a huge chain of dependencies between open source software, and one project uses a new library, and then it changes this library to another library. So oftentimes it becomes very hard to maintain all these things. And in our case, for the cloud use cases, there is the use of containers helps a lot on these things, and you can package whatever you need with the specific versions and create deployments easier through frameworks like Kubernetes. If you have, let's say, Docker containers or other forms of containers, I think this is important for the deployments, and of course this have some overhead, which is the things that everybody is more or less concerned in terms of performance. I think there is a need, and definitely there are steps towards improving the performance in such, let's say, containerized environments, hypervisors, and adding architectural support for such cases with having a hypervisor in guest operating systems. There is a need to create, of course, better software and better hardware and better hardware-software interfaces on this part. That's one of the ways we see at RIAs the use of and deployments of such big software and frameworks.
So this, sorry, but I listen to you. So that's, do you need the first word that comes in my mind is standard. So
Yes.
maybe there is, so my question is, there are, and what is the software suites that could be the most used? In this case, we are talking about Cloud Edge and IoT, right? So do you have a reference? Or do you want a reference? Because there is not. If you have to suggest to the other project, because you are working in the same call, in the same topic, let's say. So if you have to suggest this to the other, what will be your suggestion?
I don't think it's very easy to suggest, because it depends on the use cases for each specific project. What if I today say, oh, you use the TensorFlow and some other project uses PyTorch? So it's a bit not easy to suggest, but I think the major packages there are well supported, and I think whatever is widely deployed is good. Of course, the maturity of these packages in different platforms, for instance, for the RISC-V platform, it will take quite some time to reach a production state. That's why we are all contributing and trying to increase the technology readiness level, if I may call it, in these packages for specific architectures and ecosystem. I didn't answer explicitly your question, because it's not easy to compare and see all the dependencies in the use cases.
Please, Thanos.
Yes, and I would like just to say that we're talking about complex software stacks, so it's not very trivial to answer these questions. However, we are all working complementary technologies, I would say, software technologies. So we are also contributing to the task force of the architecture from EU Cloud Edge IoT, where we are recommending, let's say, we're contributing to this architecture with the technologies that we see in our projects that can be used. And I think that's something that can shape, let's say, some standardized version of an architecture for this cloud software.
I heard Stefano, but we are moving from a software to the architecture.
Yes.
Yeah, so I was just say something here, because the major goal for OpenCube is actually to to provide a reference implementation of what we believe could be the European cloud. So it's one of the tangible results. So one of the goal it is for a customer to say, okay, this is some small module, depending on your workload. It may be machine learning, it can be more like a weather forecast, or it can be some drug discovery workload. So what we did, this is the hardware, this is software stack that's being validated, and we can make a product for you to get it. So it's not exactly, to answer your question. Obviously, standard have a big impact, to adhere to standard for impact. But as a project, we wanted to provide this, reference blueprint to say, okay, this is something that we validated in the project is ready to be used and deployed, and this is the software stack, open source stack that we validated with this kind of workload. So you as a customer, we provide you this a blueprint of hardware and software that is being ready to be used.
Okay, yeah, it was a difficult question. I know, but I get from your answer, all of you were talking about RISC-V. And I get from one of the answer, I think maybe the Thanos one, I don't remember, that maybe there is something missing in RISC-V. So you are all contributing to that, right? So what do you think is missing? If I get well.
To be honest, the focus on our project is not a RISC-V. It is also RISC-V because it comes on the RIA processor, but the main focus is the ARM processor that is coming from Cyber. But we are doing also work on RISC-V, and for example, we have a synergy between the University of Manchester and CodePlay, where we want to accelerate Java applications on the RISC-V vector units that will be available on the RIA processor. So we have seen some parts from the RISC-V ecosystem, let's say. But I think Vitamin V and Riser may be more suitable to address this question regarding what is missing from RISC-V.
I don't know if you want to answer.
Vasilis, you want to answer first? Or?
Please go ahead, Ramon. I will follow.
Okay. So there are actually a lot of several things missing. So actually, both Riser and ourselves basically are developing RISC-V cores or extending the ones basically because there's some support in basically we need from the CPU. Which is required by cloud applications. For instance, virtualization that was not part of API, and actually any cloud runs on virtual systems or virtual machines. So that's one key. There are other items which actually have not even been already finalized by the RISC-V Foundation, like all the memory protection that we need. Basically, we have a cloud server or IoT. Basically, we are sharing the machine among many different applications, so we need a strong security aspect on that. So RISC-V is evolving, and that's the ISA, and that's the fundamental CPU and basically functionality that provides. Once we have this functionality, obviously we need the software that uses this functionality. Luckily, we have other CPUs like ARM and Intel, which already have that. So the software is already prepared for those chips. So it should be a reasonable effort to port this to the top of RISC-V. And that's part of what Riser and ourselves we are doing, effectively preparing the way so that whenever the chips come ready with that, the software is already there. But there's still a lot of development. I mean, it's not a matter of a couple of years to have a CPU or an ISA ready the way other ISAs that have been running for 20 or 40 years are ready at this moment.
Vasilis?
Yeah, from the side of RISE, of course, all our relevant activities around RISC-V, we see, of course, as Ramon said, RISC-V has started being adopted more and more and more. Currently, is in the phase. I would say it's not for the sovereign cloud market yet. And this is under, let's say, not under development, but it's maturing slowly. You can see RISC-V chips. You can find RISC-V chips for embedded markets or some, let's say, application class, but not server class yet. Now, this means that there will be parts in the specifications that need to be improved and involved. For instance, there have been recently several activities for the virtualization, the hypervisor extensions, the IMMU, and let's say advanced interrupts for virtualized environments. These things have been ratified recently, and there is a full software stack that needs to go with them at the low level, at the operating system and the firmware for it to work. So this thing is being developed. It will take some time to mature. I cannot tell how much. Or maybe ideally things are ready yesterday, but you have to. There are many things that are in the road. We understand more and more what is missing and what needs to be developed. And there is also the priorities. Oftentimes, I think to complete missing parts, we need to grow the community around these fields. And growing the community creates a critical mass that grows the ecosystem. And this is something that we need to focus at least to serve the server and cloud market. So it's more, the more people that work on this, the more problems we will find, the more they will solve, the better the architectures will become, the better the software will become, the better the support. So it's a growing field, and we are hopeful that from the outcomes of the RISE project, the Vitamin B, Aero, and the OpenCube, we will all help towards improving these parts also for RISC-V and the other architectures.
Yeah, I want to add in terms of timing, for instance, I was talking to these Linux distributions, and basically they were envisioning having Linux distribution at the server class, which is basically what we would need for cloud in the next 2 or 3 years. So fundamentally, I guess they are already developing that. So in the next 2 or 3 years, we should have the Linux support for server class. And effectively, that means that if any chip comes out during this time and supports this, basically, we could start seeing the first servers based on RISC-V the next 2 or 3 years. So it's a little bit beyond the time span of our project. But as Vasilis said, there are a lot of things to reach here, and there may be still more things to go further. But that's probably, if we want to set a date or to put some time frame, that's basically at least what the OS distributions are working on.
So basically, there is hope.
There is hope and interest. Basically, especially in the RISC-V Foundation and other initiatives. I mean, there are big companies there. It's not a matter of academics just pushing their nice ideas through and building up the community. So once the thing is strong enough to be competitive, then we'll see how the market reacts. And that's probably a totally different story. But still, being royalty-free almost, or de facto standard, probably it can gather a lot of momentum. So historically, Linux distribution, when they started, it seemed that it would be a birth of a feather. And effectively, nowadays, the server market is basically running on Linux. So we'll see if history repeats itself, or in the case of CPUs, it does not. But there's still history teaches us that we can be successful in this royalty-free, at least, ISA, open source.
Good. Yeah. Okay. I see that the audience is quiet, but we had a good talking. I will have another million of questions, but I think that we can close here. And I really hope that you enjoy to be here with us, and you enjoy to be here with me today. I think that we had a fruitful conversation, and I hope that we will continuously talking also besides the webinar. So I'm thanking all, and I will give you appointment to the next webinar. That will be soon. So thank you all and enjoy your day.
Thank you.
Thank you, Rosaria.
Much.
Bye-bye.
Thank you. Bye-bye.